Hi guys, welcome back to my channel. Today we're going to have a look at exponential probability functions. So first of all, let's go back and let's review what a probability density function actually is. So every continuous random variable x has a probability density function, so a probability that it's going to fall within a specific range. And it has to meet a few conditions. So the first condition is that the value of the function has to be equal to or greater than 0. So as you can see in this graph here, I don't have any values or any function that falls below that x-axis. The other important piece of information is that if I was to find the area under this curve, the area under this curve is equal to 1. And the reason for that is because there's a 100% probability that something will occur in this time frame. I don't know when, but I know that definitely something will occur within this particular time frame. So if I only want to find the particular probability between certain values, so A and B, the probability of getting a value within this range is going to be defined as the integral from these points for that function with respect to x. So the average value or the mean value of this function is actually going to be the halfway point. So the area, I can split this area exactly in half, and that's where I will find my median value. So the integral from negative infinity to my average value should be equal to a half, and similarly the integral from my average value to positive infinity should also be equal to a half. So the exponential probability density function is just a type of probability density function, so PDF value. So the exponential distribution is often concerned with lengths of time until some specific event occurs. So for example, we could say, okay, what's the probability of an earthquake occurring in the next 20 minutes, given that there hasn't been one for the past hour? So we can generally sort of define a problem like this as my function with respect to time in this case is equal to some value times by e to the power of the negative of that value over time. And for this particular function, because it's an exponential function, I'll just scroll down here so we can see this graph, we don't actually have negative values for time. And the reason for that is because we're starting off at this t is equal to 0. And so if we were to integrate the area from negative infinity to positive infinity of this particular function, that's actually going to be equal to the area from 0 to infinity. And we can find the average of that point at 1 over that value that we had from earlier. So we've got lambda representing that value here. So it's a really, really nice function. And that's because, you know, when we integrate these e to the x values, these exponential functions, you know, we often get, well, we do get another value e to the x. And so it has these really, really nice properties. So that's why we end up with our mean value as 1 over lambda. So let's go ahead and let's try and solve a problem using these exponential probability distributions. So the average life or average battery life of a laptop is about 2 hours. Determine the probability that my laptop will last between 1.5 and 2.5 hours, more than 4 hours, and 3 hours, given that it has already been on for 2 hours. So we can define this as a exponential probability function because we're looking at the length of time, and also because we're not going to be interested in time values that are negative. So that's specifically why I'm choosing to use this exponential probability function. Okay, so let's start off with this first question here. So we've got between 1.5 and 2.5 hours. So we already know for this particular problem that the average battery life is going to be equal to 2 hours long. And we also know from before that the average is equal to 1 over this value, lambda. So we can express this now as 2 is equal to 1 over lambda, and so lambda must be equal to 1 over 2. Okay, so let's go ahead and substitute this value into our function now. So we have the function with respect to time is going to be equal to 1 over 2 times by e to the power of negative 1 over 2t. So this is our function. And what we want to do is we want to find the area of that function between 1.5 and 2 hours. So I'm going to find the integral between, between 1.5 and 2.5 hours, and we're going to find that with respect with respect to t. So let's go ahead. This e function here, you could go ahead and integrate this if you already know how, so you can skip this part, but I'm just going to go through So if we're just going to find the integral of 1/2 e to the negative 1/2 t dt, what I can do is I can let this function equal to u. So u is equal to negative 1/2 t. Whoop. Let me write that a little bit bigger, one sec. Negative 1/2 t. There we go. So let's find the derivative of this function. So du dt is going to be equal to negative 1/2. And I'm going to rearrange this now to express in terms of du. So du is going to be equal to negative 1/2 dt. And so dt is going to be equal to, if we multiplied both sides by -2, that would get rid of this negative 1/2 at the front here. So I end up with dt is equal to -2 du. And then what I can do is I can substitute those values into my function. So I have the integral, and I'm just going to pop this 1/2 value at the front. So 1/2 of the integral of -2 times by e to the power of u du. Okay, so now when we integrate this function, this is going to become 1/2 of -2 times by e to the u. So this is going to become negative e to the u plus c, but I'm not going to put that plus c in for the minute. So then I'll replace my function with u. All right, so now what we can do is we can go ahead and we can substitute in those values 2.5 and 1.5 to find the solution for this integral. Okay, so if we wanted to express our solution as an exact answer, we could do this, and we can use a very specific notation when we do this. So we're going to write p 1.5 less than or equal to t less than or equal to 2.5 will be equal to e to the power of -3 over 4 minus e to the power of -5 over 4, which is going to be approximately 18.59%. So there's about an 18.59% that my laptop is going to die within the next however many minutes. Let me have a look. Between 1.5 and 2.5 hours. Okay, let's have a go at this second question now. So determine the probability that my laptop will last more than 4 hours. All right, let's think about what's actually happening here when something is going to be lasting for more than 4 hours. So this is going to be my exponential function here. And so this might be the point, oh, this is going to be pretty rough. This might be the point where it's going to last for 2 hours. And then this might be the point, say, where it's going to last for about 4 hours. So this was my average value here. Now, what I'm asking is I'm asking that it's going to last for longer. So however long this line or this function continues on for, I'm going to say it lasts longer than that amount of time. So this area is effectively going up to infinity. So we're looking for the integral of this function between the areas of 4 and infinity. So again, we can just use the same method that we did previously to find the value of this particular integral. Now all I need to do is substitute in my values. Since we're going to positive infinity though, I want to think about what's happening. So as we go and we're increasing this value here, 1/2 times infinity is just, well, it's just going to become infinity really. And this is going in the negative direction. So this value will actually be negative e to the power of negative infinity. So what does this actually mean? So this is the same saying -1 over e to the power of infinity. So this is a very, very small number. And as this number tends towards infinity, the value of this is going to tend towards 0. So that's why I'm going to put 0 as my first term. Take away negative e to the power of -2. So this is going to become our value for our solution. So this has a decimal answer of 0.1353, so that's going to be about 13.53% chance that my battery is going to last longer than 4 hours. So again, using our correct notation, we're going to write the probability that it's the timer is going to be longer. That the time will be greater or equal to 4 hours is going to be equal to about 13.53%. Okay, the last question was asking us, hold on, let me just scroll up here. So the average battery life of the laptop is 2 hours. Determine the probability the laptop will last 3 hours, given that it has already been on for 2 hours. So let's draw a diagram of this scenario. Okay, so let's think about this conceptually. If I know that my mean value is going to be 2, right? So this value here, this is going to be equal to a half. So there's a 50% chance that it's going to, the battery life will last for 2 hours. So what that means is that there's going to be a 50% chance that it's not going to last after that time. Now we've been given some extra information, so that given that it's already been on for 2 hours, effectively what that's doing is that's reducing my sample space. So now I'm only actually going to be looking at this information here, and I'm going to be I want to pick a color, but I want to pick a color that everyone can see. If I just do a highlight, everyone should be able to see that. So given that I've already know that it's lasted for 2 hours, what's the probability now that it's going to last for longer than that 3 hour mark in time? So we've reduced our sample size to just this area of the graph that's in red. So we can use that probability formula. So I'll just pop that on screen. Okay, so I've written out this probability formula now, and I just sort of want to go through and explain a little bit how this works. So the probability that it will last longer than 3 hours, given that it's already been on for 2 hours, is going to be equal to the probability of A and B. So in other words, the probability it's going to be longer than 3 hours and longer than 2 hours. So effectively just saying longer than 3 hours. In other words, just this highlighted part here. And that divided by the probability of being longer than 2 hours. So if I highlight this part in purple, and this is equivalent to that entire area under the graph. I don't want to do too much over that yellow though, but including that entire area that was originally in red. And that's just going to be the probability that t is greater than or equal to 2 hours. So from 2 to infinity. So let's go ahead and let's actually calculate these values. So this first one here in yellow, this is going to be the integral from 3 to infinity for our original function with respect to t. And then let's keep that highlighted so we know what's going on here. And we're going to divide that through by this entire area. So this entire area is going to be from 2 to infinity. So the integral from 2 to infinity for our particular function with respect to t. And this is that bit in purple. So that would include this entire area that I was talking about. So this is going to get a little bit complicated. Let's do this highlighted part in yellow first, then we'll work out this part in this purpley color, and then we'll go ahead and finish this sum. All right, so I've just used that integral function from before, and for this one we've gone from 3 to infinity. This one, again, same thing, except we've gone from 2 to infinity because this was my answer from before from yellow, and then this was my answer from before in purple, so this entire area here. So what I'm going to do then is we are now going to substitute that back into this formula, so that P of A given that B has occurred formula, and that's going to be equal to e to the power of -3 over 2 divided by e to the power of -1. So I'm just going to pop this in my calculator. So we have a 60% chance of it lasting longer than 3 hours, given that it's already lasted for 2 hours. I feel like my maths has gone off somewhere. I'm just not sure where. That value seems a little bit high to me. Anyway, so that is how we find, how we use exponential PDF functions in order to find the probability that something's going to occur within a given time frame. All right, guys, I hope you enjoyed. I will see you in the next video.